Our topic for this session, the title I've selected, Multiple Lines of Evidence That the Earth is Young. There's a ferocious assault today against the foundations of Christian faith and ultimately against the authenticity of Jesus. And at the heart of this assault is the issue of the age of the earth. And I would say for the past 200 years, Satan has been directing a massive campaign to rewrite the physical history of the earth in the minds of the human race. And what has been Satan's chief strategy on this front? It is the deception of deep time, that the earth and cosmos are truly billions of years old. Satan's goal with this deception of deep time is to contradict the historical aspects of God's Word and therefore to destroy its authority in the minds of people. Plain and simple. I say, do not be misled. Deep time is a direct assault, a devastating assault on the truthfulness of God's Word. And part of the reason I was invited here this weekend was what is going on in one of the churches here in town, where it's openly being taught and advocated that indeed the earth is old, that the basic story of evolution is true, and that in effect that you cannot take the first 11 chapters of Genesis at face value. In particular, it's one implication is that there was not a literal Adam and Eve. There was not a literal global flood. So again, when you start denying essential aspects of God's Word like that, that is serious business. I would say it's in the category of a false prophet, and I believe that those kind of people need to be called out today. It's time for us not to be playing around and accommodating that kind of error in our midst. So I'm disappointed that none of those people involved in that campaign are here today. But I responded to the call because of the passion of people that were upset about that situation. So that's just mention that was part of why I came this weekend, to help. Okay. So the claim that the earth is millions and even billions of years old has ruled as dogma in academic circles since the time of Lyell 200 years ago, and has faced no serious challenge in the last 100 years, since the early part of the 20th century. That claim, I'll repeat, that claim has not had any serious challenge since the early 1900s. But let's look at some of the inescapable implications of the timescale of uniformitarian geology. All right, some of the implications. One implication is there was no perfect original creation that included human beings, as Genesis chapter 1 implies that there was. Secondly, modern humans, this time scale, long time scale, implies that modern humans, anatomically modern humans, have existed for more than 150,000 years. It's more like 300,000 actually. But Genesis 1 and 11, if that's right, that means Genesis 1 through 11, chapters 1 through 11, including the genealogies, therefore cannot be historical, cannot be taken in a historical way. Furthermore, that time scale implies there was no global flood. Within that time scale, there simply has been no global cataclysm. So it rules out, that framework absolutely rules out a global flood. The next point, the Bible therefore is not reliable on issues pertaining to geology, anthropology, archaeology, cosmology, or history. And then finally, Jesus Another implication of that time scale, Jesus, since he endorsed the Genesis text as real history, since he clearly endorsed features of those 11 chapters, first 11 chapters, that means Jesus was in error and logically cannot be deity. So it's an assault on Jesus himself. So we have that going on in a so-called evangelical church right here in Los Alamos, the largest evangelical church in town, I think I've heard. So it's time that they face up to what the seriousness of that path that they have chosen. The widespread acceptance of the uniformitarian view of history of the world has decimated biblical Christianity in Europe. These vast cathedrals are largely empty. A handful of old people may show up in these cathedrals that even still have services. So it has resulted in just a dramatic decline in the number of evangelical people in Europe. So the consequences are severe when church leaders take that position. So why has uniformitarianism and this idea of an ancient earth been such a formidable stronghold, so difficult for those loyal to Jesus to overthrow over the last 100 years and more? Well, I would say the main reason is what's known as radioisotope dating. By 1905, it was realized that the decay of uranium to lead could be used to estimate the age of rocks. From an early determination of the uranium half-life and the measured amounts of lead in some of the first rocks analyzed, it was soon accepted throughout the academic world with a high degree of confidence that the Earth was more than 1 billion years old. For secularists in general, and atheists in particular, it was a time for jubilation. For them, the radioisotope data established beyond any serious doubt that the Earth was billions of years old, that evolution had to be true, and that the Bible was no more than a myth. So, what is meant by a radioisotope? Well, this little animation illustrates the process of alpha decay, an alpha particle being released from a plutonium-239 nucleus, and also gamma rays being released, and that nucleus then becomes a uranium-235 nucleus. So that's an example of what we talk about, what we mean by a radioisotope, one that's unstable and changes into another element spontaneously. So what do we mean by half-life? Well, half-life, it's a simple concept that as a result of this spontaneous decay, it's the time it takes for half of that original number of atoms to disappear, to transform to the other type of atom. So if the half-life, for example, is 3 days, if you start with 1,000 atoms, after three days, you'll have approximately 500. After another 3 days, about 250. After another 3 days, about 125, and so on. So it's something that can be measured in the laboratory. And in general, because there are so many atoms in a small amount of material, it's possible in a reasonable amount of time to measure half-lives of isotopes that can have a half-life of billions of years. Like uranium-238. That half-life can be accurately measured because there's just a huge number of atoms, even in 1 gram of uranium. Because radioisotope data represented such a formidable and unanswered challenge to biblical authority, in 1997, the Institute for Creation Research launched an initiative to identify the fundamental error or errors in radioisotope dating methods. And mainly under the leadership of Dr. Larry Vardaman, who was on the staff of the Institute for Creation Research, there was a team of 7 Ph.D.s assembled, including Dr. Vardaman, for this task. It's the 7 individuals on the front 2 rows in this photograph that happen to include me. The others, Larry Vardaman's in the center there on the front row, Russ Humphreys on the right, then on the next row is Andrew Snelling, Steve Austin, Don DeYoung, and Eugene Chafin. Those 7, we were the original members. In this particular photograph, on the back row is on the left is John Morris, who was at that point president of ICR. Ken Cumming, who was the dean of the graduate school. Bill Hosch, who was a lab assistant for Steve Austin. And then Steve Boyd, we brought on board late in the program. He's a Hebrew scholar, and he worked on the Hebrew of Genesis 1 to 11 for us. Okay, some of the findings. One is that C14 is now our friend as Bible believers. The rate team confirmed that C14 is present in coal at levels far above the detection limit of modern C14 methods. The standard uniformitarian ages assigned to the portions of the rock record from which the coal samples were taken are in the range of tens to hundreds of millions of years. And yet we found C14 far above the detection levels in all of the samples. This is a huge discrepancy because C14 is undetectable after 100,000 years. So that was one of the key results. So how old is coal? Well, C14 indicates it is only thousands of years old, not hundreds of millions. And actually reports that organic samples from every portion of the fossil record contain significant and repeatable levels of C14 has been buried in the peer-reviewed C14 literature for more than 20 years. This inconvenient truth has been dismissed. This presence of C14 has been dismissed as, quote, in situ contamination and ignored on the part of the professional community. But in the literature, you find here we document in our report 75 peer-reviewed papers that document these high levels of C14 in a wide variety of materials in the fossil record. That in materials whose ages, their location in the geological record imply they ought to be completely C14 free. So here we see some examples, and the C14 age that is reported in these peer-reviewed papers. Things from marble, shell, foraminifera, whalebone, wood, and coal, and so on. So as part of our effort on the rate team, we obtained 10 of our own coal samples from the U.S. Department of Energy Coal Repository at Penn State University, had these samples analyzed by one of the best C14 labs in the world. And the 10 coal seams from which the samples were taken had standard ages ranging from about 40 million years to 315 million years, and represented different major economic coal deposits across the United States. And basically, our results simply confirmed, fell right exactly in the same range that was already in the peer-reviewed literature. We obtained ages from between around 44,000 and 57,000 years for our samples, with the average being just under 50,000 years. So we verified that indeed measurable C14 existed in all our samples, and essentially all the samples had very close to the same amount of C14. So this, like I said, merely confirmed what was already well documented in the standard peer-reviewed C14 literature. So this shows the span of ages in thousands of C14 years versus the number of samples, and what it suggested. They spanned a large fraction of the fossil record. As I mentioned, statistically, we saw no difference in C14 levels from the youngest to the oldest samples. This suggests, at least at one level, it suggests that plants comprising these separate coal deposits all grew on Earth at the same time and not so long ago. Why is finding these levels of C14 such a big deal? It's because C14 does not last forever. The half-life after 10 half-lives, you have only 1/1000th of the original amount remaining. So how long does C14 last? Well, the half-life of C14 is 5,730 years. So after that length of time, you'd expect half of it to be gone. After 10 half-lives, that's 57,300 years, you only expect to find about 1/1000th or 0.1% still remaining. But after 1 million years, you would expect to find only 52 zeros and then a 2 after the decimal point. 2 times 10 to the minus 53 of the original amount. And then just to give you some idea what that means, if you started with a quantity of C14 equal to the mass of the Earth, take the mass of the Earth, but solid C14, that consists only of 3 times 10 to the 50th atoms. Therefore, if you had the amount of decay which would take place in 1 million years occur, you would expect not a single atom left after 1 million years of that starting amount of C14. Hence, finding C14 in anything 1 million years old or older, unless it has been contaminated with modern carbon, is impossible. All right, so obviously there's a huge discrepancy here. But if you take the Bible seriously, you would ask, well, why did our samples give C14 ages of about 50,000 years when the Bible, taken at face values, implies the creation took place only about 6,000 years ago? Well, the answer is the C14 level in the atmosphere before the flood, when these plants grew, was almost certainly different and lower than it is today. So what I'm trying to show in this slide is that C14 is with respect to the C14 level in the atmosphere when the organism was alive. And so when an animal dies, it no longer takes in new C14 from the atmosphere, and that's when the clock starts ticking, when it dies. If the organism, the plant or animal, when it grew, if the atmospheric level was lower, it would start off with a lower level of C14, and the final level after a given amount of time would be lower than it would be if the animal plant or animal had lived today. So the presence of so many more plants and animals together on Earth before the flood means there was much more C12 in the biosphere in the pre-flood world. This additional C12 conceivably diluted the available C14, probably by a factor of at least 100 compared with today. This made the atmospheric C14 to C12 ratio 100 times smaller in the pre-flood world today, and taking that into account gives the C14 levels we now detect in coal and other fossils to imply that they lived only roughly 5,000 years ago instead of 50 million should have been there. Okay, so in summary, the C14 levels we measure in coal today argue powerfully that the trees which transformed into coal lived thousands, not tens or hundreds of millions of years ago. So that was one of the multiple lines of work we did as part of this RATE project, Radioisotopes in the Age of the Earth. But the really big issue is, why do other radioisotope methods give such vast ages when applied to the Earth's rocks? Why do they give ages in the range of millions, in some cases billions of years? So the approach our team took was to face up to the reality that most of the Earth's rocks actually contain millions to billions of years worth of nuclear decay products, not merely a few thousand years worth. Our objective was to try to understand why such high levels of nuclear decay products exist, given that, according to the Bible, the history of the world since creation spans only a few thousand years. Let's look at the assumptions that underlie these standard long half-life radioisotope methods. These assumptions include that the rock sample has remained a closed system since the rock cooled from a molten condition and crystallized. So that's an essential assumption. And when you do apply these methods, you're looking for indicators that assumption may not have held, and you can discard those samples if there's indication that sample, if it's not been a closed system. But that's essential to get a correct measurement. A second assumption is that the initial amounts of the daughter products, the daughter elements produced by the nuclear decay, can be accurately known. So that's an important assumption. And the third assumption is that nuclear decay rates have remained unchanged throughout Earth history since the rock crystallized. So in order for these methods to give correct dates, all three of these assumptions need to be true. Now, the validity of the first two of these assumptions for a given rock can be checked by applying what is called the isochron approach. But how can the third assumption be tested? Namely, that nuclear decay rates have remained unchanged through Earth history. Well, a breakthrough discovery on the part of our team was that assumption can be demonstrated not to be true. That nuclear decay rates have not been constant. They've been dramatically higher in the past. So just what sort of work, what kind of research has demonstrated that? Well, one line of more than one sub-projects that we had, one of those methods was measuring the helium retention in zircon crystals. And these measured levels imply that 1.5 billion years worth of uranium decay to lead at today's decay rate has occurred within the last 6,000 years. A radical discovery on our part. Now, what are zircon crystals? Well, here's a photo of some of the crystals that we used in our work. They typically are transparent. In some cases can be brown or yellow, but commonly are almost clear. These are crystals of zirconium silicate, ZrSiO4, and they turn out they're very hard, and they're ideally suited. They're like little time capsules for uranium decay, and the reason is that uranium atoms substitute readily for zirconium atoms in the crystal, so that zircons tend to incorporate up to about 1% uranium when they form. Secondly, so they're radioactive. They contain uranium. Secondly, zircons tend to strongly exclude lead when they crystallize, so which is a uranium decay product, which is convenient since we can with confidence assume that there was zero initial lead in these crystals. And thirdly, zircons have a high melting temperature and mechanically are extremely hard, so that the idea that they have been intact since the time they crystallized is generally the case, generally true. Now, the zircons we studied were from a drill core from a 4-kilometer deep hole, about 2.5 miles deep, in granitic crustal basement rock in northern New Mexico, just on the other side from us here, from across the Jemez caldera, near Fenton Hill. And so that's where the samples were taken. Let's see, do I want to go into that? Well, yeah, I'll show. This slide shows the 14-step decay chain of uranium-238 to lead-206. Now, this process of decay from uranium to lead involves the emission of 8 alpha particles, which consist of 2 protons and 2 neutrons. And very quickly after the alpha particle is emitted, it captures 2 electrons and becomes an atom of helium. So the two stable decay products of uranium-238 decay are lead-206 and helium. So uranium decay yields lead and helium as stable end products. So as these uranium atoms decay successively down to lead, you have 8 alpha particles produced, which rapidly become helium atoms. So if the zircon is moderately large, most of those atoms are retained within the crystal. They're not able to escape. They don't have enough energy to burrow their way out of the crystal. So we were looking at larger crystals that trapped most of those alpha particles. However, just as helium leaks out of a party balloon, in a similar way, helium leaks out of a zircon crystal. So helium diffuses through the zircon into the surrounding environment, which in our case, these zircons are commonly embedded in biotite crystals. So as time goes by, the zircon diffuses through, the helium diffuses through the zircon crystal and escapes. However, the zircons we studied still retained large amounts of their helium. And this column on the right shows the amount of the percentage of the helium that was retained in these zircons. The percent of 1.5 billion years worth of uranium lead decay. We could used the standard uranium-lead dating on these crystals, and they showed the amount of lead that you would get from 1.5 billion years worth of decay. And yet, we found large fractions of that total amount of helium still present in the crystals. And at the shallowest depths, rock from the shallowest depths, which had the lowest temperatures, those crystals retained up to 80% of that 1.5 billion years worth of decay. And the reason that the percentage retained decreases with depth is that the temperature goes up fairly rapidly with depth, and the rate of leakage depends on temperature very strongly. So as you go to higher temperatures, you would expect the amount of helium retained to be less, and that's exactly what we found. And actually, these measurements shown in black were actually done at Oak Ridge National Laboratory back in the early 80s by a researcher by the name of Robert Gentry, and reported in the Geophysical Research Letters in 1982. So already, when we began our project, we were aware of those results. The two data points in sort of the purple or magenta color were measurements that we did to verify. Our results fall exactly in line with what Robert Gentry had found more than 20 years earlier. So a major research issue for us was measuring the rate of diffusion of helium in zircon. At the beginning of the RATE project, we knew that such high helium retention levels were not consistent with a 1.5 billion year uranium-lead age assigned to these rocks. We had evidence that helium would diffuse away in a much shorter time than that. Yet without knowing the actual diffusion rate of helium in zircon, we could not make a strong case that they were much younger than 1.5 billion years. We therefore launched a major initiative to obtain these critical measurements. We obtained samples from the same core that Gentry had studied, and it turned out that core was stored and presumably is still stored right here at Los Alamos. We were able to get permission to take samples of it, and we sampled it at two depths, different from what Gentry sampled. One depth at 750 meters, another at 1,500 meter depths. And we crushed, sieved, and separated the zircons, crushed the rock, and actually sent them to a lab in Canada for separating out the zircons. And the zircons we obtained were the same size as those studied by Gentry, in the range of 50 to 75 micrometers. And we contracted with the world expert to measure the helium diffusion rate. And we sent, and this is the apparatus that was used, and it was purely a contractual relationship. The guy that measured our samples did not know who the sponsor was, what our goals were, or the site from which the samples were obtained. So it was really was a truly blind experiment as far as that measurement was concerned. Now, back 3 years before we actually were able to make the measurements, we published an estimate of what the diffusion rate might be. We had two. This plot shows two curves. One, if the diffusion rate were such that if the rock were 1.5 billion years old, it would imply low diffusion rates. On the other hand, if the rock crystallized only 6,000 years ago, it would imply much higher diffusion rates. The difference was a factor of about 100,000 in the diffusion rates. And these these points that you see here are taken from the retention levels that Gentry reported, and all of those are from what Gentry reported. Okay, now when we actually got the results back, we could hardly believe it, that the actual measured diffusion rates fit the 6,000-year prediction within the 95% confidence limits. You can see the blue dots there. Those are the actual measurements, and they fall right on the 6,000-year curve. And you see the error bars from the measurements given by the experimenter who measured them. So within those error bars, it falls right on that curve. And these are truly astonishing and indeed revolutionary results. How are they to be explained? I'm sorry. Well, how could there be most of the 1.5 billion years worth of the radiogenic helium still inside these crystals when direct laboratory measurement of the helium diffusion rate shows that most of that helium ought to have been lost in only a few thousand years? Well, we believe, well, first of all, what we have here, the issue we've got two clocks in the zircon that are based on two distinctly different physical processes. And these two clocks disagree by a factor of 250,000. The one clock is based on presently measured nuclear decay rates of uranium. And that clock would give an age of 1.5 billion years. That is the age it gives. On the other hand, the helium diffusion clock, measured on how fast helium escapes out of zircon, indicates an age of only 6,000 plus or minus 2,000 years. So what could explain, what could account for this discrepancy? Well, we, based on these results and others we did, we believe that the explanation is that nuclear decay rates must have been much higher during brief intervals in the Earth's past. And during those brief intervals of high nuclear decay rates, especially for long half-life species like uranium and uranium daughter products, that the clock, based on that nuclear decay, ran up vast amounts of time in a real time of a very short duration, while the diffusion properties of the zircon were not affected by the things that affected the nuclear decay rates. And therefore, the helium diffusion clock shows only about 6,000 years of accumulated time. So our study of the helium retention in zircons, again, in summary, showed 1.5 billion years worth of nuclear decay had occurred within the last 4,000 to 8,000 years. And that conclusion logically implies that nuclear decay rates have not been constant, but instead have been dramatically higher during episodes in the past. This is a paradigm-shaking conclusion. So we had actually another project, which I don't have time to go into, having to do with polonium halos, also produced by uranium decay in zircons, which also conclusively demonstrated exceptional rates, extreme rates of nuclear decay in order to produce enough polonium in a short period of time to produce these polonium halos. So our conclusion was that nuclear decay rates were vastly higher during episodes in the past than they are today, and that radioisotope dates based on the assumption of constant nuclear decay rates are in error by large factors, huge factors, that factor of 250,000 that I showed. The implication of this work is that the concept of deep time, grounded primarily upon radioisotope dating and constant nuclear decay rates, is false. And those who hold the Bible to be God's Word no longer need to be intimidated by radioisotope dating methods and the millions of year ages they routinely give for the Earth's rocks. And the three projects that led the RATE team to this firm conclusion was presence of C14 in coal and other carbon-bearing fossils from deep in the geologic column, the high levels of helium in radioactive zircon crystals and granites, and polonium radiohalos in granite and metamorphic rocks. I don't have time to go into detail, but we produced an 800-page technical report on these projects, and each of those chapters is downloadable for free on the web from as separate PDF files. So if you're interested in the technical details, those chapters are available. I recommend the one on C14, Chapter 8, that I wrote, and the Chapter 2 on helium retention in zircons, which Russ Humphreys wrote. And the polonium halos, radio halos in granite, that chapter Andrew Snelling wrote. And it's also a powerful documentation of rapid nuclear decay. But there are many other persuasive indicators that the Earth and human race are young. Let us briefly consider a few quickly. One, soft tissue preservation in fossilized organisms. I've already, in the last talk, briefly alluded to that. A number is the small number of human mitochondrial DNA mutations. Another, this third one I've already alluded to, the persistence of human genetic fitness given the present high measured mutation rate in the human population. Another one is the recent abrupt appearance of human civilization in the archaeological record, and also in the archaeological record, the small number of Stone Age graves. Their list I could make this list many times longer, but I'm just going to focus on these indicators. I already mentioned the soft tissue preservation in the T-Rex bone reported in Science magazine, work done by Mary Schweitzer in 2005. Astonishing, flexible blood vessels containing red blood cells. But since this time, there's been several other reports. Here's another report by Mary Schweitzer from 2009. And this is from a hadrosaur, a duck-billed dinosaur, soft tissue. Again, this case is showing osteocytes, bone cells with nuclei and connecting fibrils from the hadrosaur bone. The figure on the lower left show these well-preserved osteocytes that still real proteins, still flexible osteocytes in this hadrosaur bone. This is some more work by Mary Schweitzer. Blood vessels from demineralized Brachiolephosaurus bone, another kind of dinosaur. Again, well-preserved, flexible blood vessels from still yet another dinosaur. This is a hadrosaur also. And then this list is too small to read, but these are recent publications documenting soft tissue preservation in a wide spectrum of different organisms over the last 20. Well, the earliest one shown here is from 1977. The second one is osteocalcin from the Seismosaurus, which that work was done right here at Los Alamos in the early 1990s. But live protein from a halite deposit from From the Whip site down in southeastern New Mexico, they found viable bacteria in some of that salt. It's hard to believe that bacteria would survive for 250 million years and still be alive. Okay. So just a whole host of examples of soft tissue preservation. And I believe those by themselves argue for a young Earth. A second point is a small number of mitochondrial DNA mutations suggest that the human race has existed only for a few thousand years. Some of you may be asking, well, what is mitochondrial DNA? Well, we've already looked at what mitochondria are. It's where these ATP synthase motors reside, and it's where these mitochondria basically are sometimes called the powerhouse of the cell because they generate most of the cell supply of usable chemical energy. But it turns out in each mitochondrion there is a circular loop of DNA that code for some of the structures within a mitochondrion. And this little small loop of circular DNA has 16,569 DNA base pairs. And so it turns out that we inherit our mitochondria from the egg of our mother. And so all this mitochondrial DNA comes through the mother. None of it comes through the father. An amazing discovery, some research has found the actual mitochondrial DNA sequence of a common female ancestor for the entire human race. That has now been worked out because we've sequenced so many human genomes that we're able to pin that down. And it turns out that the Rob Carter, a good friend who works for Creation Ministries International, he's got a Ph.D. in marine biology. He worked that out, published it in Nucleic Acid Research in 2007. So some key findings relative to this mitochondrial DNA in our common female ancestor is the small amount of observed variation. Today, on average, our mitochondrial DNA differs from the consensus sequence that I mentioned just now at only 22 out of the close to 17,000 locations. So there's a tiny amount of variation in our mitochondrial DNA. On the other hand, as far as estimating the mutation rate of mitochondrial DNA, it's observed to be high, about one mitochondrial DNA mutation for every 10 to 20 human generations. This suggests only about 200 to 400 generations of humans have existed since our common female ancestor. And when this was starting to be discovered in the late 1980s, some of the popular news magazines referred to as mitochondrial Eve. So that's a fitting description of what we have here. Okay, so that basically argues for a young human race. Another evidence that humans have not been around for 150,000 years or 300,000 years, but only a few thousand, only 6,000 to 8,000 years. Just the small number of mitochondrial DNA mutations. Also, in the last talk, we saw that because natural selection cannot detect, much less eliminate, most bad mutations, genetic decline is genuine and strong. In the case of humans, with a minimum average mutation rate of at least 100 new mutations in each child born, genetic decline limits the lifetime of the human race to only a few hundred generations, or just a few thousand years. So that's another another argument for a young human race. And I talked about this slide in the preceding talk. And then another argument that the human race, at least, is young is the recent abrupt appearance of human civilization roughly 5,000 years ago. Here's a chart from a Wikipedia article entitled Cradle of Civilization, and it shows that looking at the civilizations in Egypt, India, China, Central America, the Middle East, and Greece, that all these civilizations appear to have appeared suddenly out of the blue about 5,000 years ago. So the criteria that were used to develop this chart involved the presence of writing, the cities, agriculture, government, and a division of labor. So all of these features that we understand to be elements of human civilization just suddenly appeared on the scene about 5,000 years ago. And finally, the small number of Stone Age graves. This is a grave site discovered in Russia, dated what's called Upper Paleolithic. Radiocarbon age is 28 to 30,000 years, which, like I said, has to be much less than that in reality. And here's a quote from a paper published on this discovery. The problem is that these burials are so rare. There's just over 3 per 1,000 years for all of Eurasia. That means during the Upper Paleolithic. So if there were, say, an average population of 10,000 humans spanning 100,000 years, you'd expect millions to billions of graves, since it was clear that humans were burying their dead during that era. But where are the graves if that was the case? It's evidence that there wasn't this huge span of time since modern man has been around. So if we assume a Eurasian human population averaging, here's 100,000 individuals with an average lifespan of 40 years, then during the 30,000 years of the Upper Paleolithic, you'd expect 75 million people would have lived and died. Why then do we find less than 100 graves? So, in conclusion for this particular talk, there's on one hand a ferocious intellectual assault raging against the foundations of biblical faith. And at the heart of this assault is the issue of the age of the earth. But on the other hand, praise God, as those loyal to Jesus, we no longer need to be intimidated by radioisotope dating claims that the earth rocks are millions or billions of years old, when the Bible indicates that God created all things only a few thousand years ago. And there are many physical lines of evidence that support the God-breathed biblical text. So just to help you maybe try to sort things out a little better in your mind, I've reproduced the standard chart of geological history with the standard names of the geological eras, and put on them the time that these rock layers would have been deposited or formed in terms of biblical history. So we have basically the Precambrian rocks representing creation, when God formed the earth. We would have Adam alive right at the end of that period, and then the flood covering basically the what's called the Paleozoic, Mesozoic, and almost all the Cenozoic or in other words, the Phanerozoic part of Earth history, that is that part of the rock record that contain multicellular fossil organisms that would correspond to the flood, which lasted only about a year according to the Bible. And then the very topmost part, corresponding to what is generally called the Quaternary, would span the last roughly 4,000 to 5,000 years and include the Ice Age. But that time would be from the time of Noah to the present, include the time when Abraham lived and when the Lord Jesus lived. So that is the geologic history according to Scripture. And so with that, I might mention there is a paperback. I didn't have it available today, but a 190-page paperback covering the primary rate results written for the non-technical person, called Thousands Not Billions, Challenging an Icon of Evolution, Questioning the Age of the Earth. And then there's this 800-page technical report giving the detailed technical descriptions of these 8 rate research projects. Individual chapters are available free online at this website, www.icr.org/rate2. Actually, I should have changed that. They're directly available there under the address icr.org/rate2. But they're and I've got one of those, or maybe two of those out there on the table to look at. So thank you very much. We do have a few minutes before 12 when we had scheduled lunch. So if there are any questions you'd like to ask, we've got a couple of minutes to discuss. I'll start over here.
So let me just preface with, as a Christian, I understand how you would think that it's a direct attack on Christianity. As a geologist, I vehemently disagree with that it's contradictory, that it is an attack. In addition to that, I believe that the propagation and continued denial of the age of the earth is actually harmful to people's faith, which obviously was not your intention, but I believe that is in part why there's such skepticism about Christianity in the scientific community.
Well, I certainly understand your position. There are ministries devoted to arguing that position. Ministry called Reasons to Believe, and they make that point. They consider that what I'm sharing with you today to be destructive, harmful to Christian faith. They believe that the evidence is so overwhelming that the earth is old, that for somebody to deny it, it makes Christians out to be idiots. And I say, well, let's talk about it. Let's talk about it. I would say, come back this afternoon and we'll look at geology. We'll look at the geological evidence. And I have a Ph.D. in geoscience, geophysics. So I will take you. I'll entertain. We can debate these issues, and I'll argue that the evidence is overwhelming that there's been a major cataclysm in the Earth's past, and that the current geological interpretations of the geologic record are faulty. They ignore major aspects of the geological record. And so we can I say, let's get the evidence out in the open. Let's talk about it. I certainly appreciate how you've been trained. Any kind of professional training in geology is in my view, very heavily weighted toward this uniformitarian framework. That's generally the only side you hear. And so I say, let's get the evidence out on the table. Let's look at it. Let's look at the evidence for that whether or not there has been a major cataclysm in the years past. And I say the Bible, you throw out the account of the flood, you rip that out of the Bible, you're doing great damage to the authority of the Bible. And I say, as I said earlier in my talk this morning, to me, that's tantamount of that's putting you almost in the category of a false prophet, of the kind of false prophets the Bible talks about. So it's serious for you to be articulating, advocating that position, claiming you're a Christian, which a position that calls into question the authority, the authenticity of Jesus.
Along those lines, you mentioned a verse where Jesus refers to Genesis. I'm not familiar with that verse, that he puts forth a literal interpretation of Genesis.
Let's just take
that wasn't meant to be attacking. I'm actually not familiar.
No, well, let's just consider Matthew 24, verses 37 to 39. I'm not sure I've got it totally memorized, but
5:29 through 30.
Pardon?
Matthew 5:29 through 30 and Matthew 7:4 through 5.
Okay, well, I had another one, Matthew 24, 37 to 39. For just, yeah. So that the one in Matthew 24 says, for the coming of the Son of Man will be just like the days of Noah. For in the days which were before the flood, they were eating and drinking, marrying and giving in marriage, up to the day Noah entered the ark. And they did not, see, this NIV says, they knew nothing about what would happen until the flood came and took them all away. That is how it will be at the coming of the Son of Man. So here Jesus is putting his stamp of authority on the historicity of a flood that certainly destroyed all the human race. But if you go back to Genesis, so he put his stamp of authority on that account written in Genesis that Moses at least edited, and Moses' authority rested on that. So I would say that's one example of where Jesus placed his stamp of authority on those first 11 chapters. It also refers to the historicity of Adam and Eve several times. And so this other framework makes it impossible for them to have been a literal Adam and Eve. Because Adam and Eve in Genesis are linked with very clear genealogies from Adam and Eve to Noah, for example. And that spans only about 1,650 years. And there's no way to put...
By that logic, though, we're all blasphemous for having both our eyes and both our hands. Matthew 5, 29 and 30. If we sin with our eyes or our right hand, cut them off, pluck them out.
Okay, well...
If things are to be taken literally.
Well, I say that, these are historical. What I'm talking about has to do with the basic history that the Old Testament lays out, the history of the world. And I say if you want to, it sounds like you're attacking any kind of literal understanding of the Bible.
Some things that need to be taken literally and some things that don't. Like the verse that either should not or don't need to be.
Okay. Well, let's talk about that later. I'll give Chuck another shot here.
I'm going to talk about the following. If you look at tree rings, we can trace some trees back 10,000 years. That's almost twice as far as you're suggesting. If you look at stalactites...
Well, wait just a minute. You don't have individual trees with 10,000 rings.
What's that going to do?
Well, what you've got to do is somehow do tree ring matching.
Yeah.
And
Science and it works.
well, I would say there's more subjectivity than I think you understand involved in the process.
Stalactites and stalagmites, they're all layered too, and you get enormous layers. Finally, if you look at ice cores, Greenland, 130,000 layers. We know they're yearly layers.
No, we don't. I would say you can't demonstrate that they're yearly layers. After a few hundred feet, the ice recrystallizes and the layers themselves disappear.
They're still separated by thin layers of sediment.
Right, you do. Right. You do have layers of ash. You do have layers there, and basically the way people get the ages is use radioisotope methods on those ash layers. So again, the claim that you have all these individual layers that you can count is disingenuous.
Yeah, but there you go to Antarctica and it goes down 700,000 years. And you can play with the numbers all you want, but you ain't going to get 6,000 years out of the 1.5 mile deep ice in Antarctica. You're not going to do it.
Oh,
But
okay.
if you determine that the scriptures have to be literal, then you can tangle yourself up with an argument that nobody would believe. And sure, you can say, therefore, 1.5 miles of ice is only 6,000 years old. But come on.
Well,
This gentleman's right. You make other people think there's something the matter with Christianity when there isn't. And finally, I take a little exception with the fact that this whole organization in town, the Los Alamos Forum for Faith and Science, made up of people from 6 or 7 different denominations, all of whom are scientists and people of faith, that somehow they are driven by Satan. I take a big exception to that. We love God and we think He's fantastic.
well, I'm saying that Christians can be sincerely deceived. Christians can be sincerely wrong.
Yeah,
And I say,
that's possible. And guess who are the ones who are deceived?
well, we all, deception is a really awful thing because in general, a person that's deceived is oblivious. He's oblivious to the deception he's bought into. So I myself.
Once you say that, then there's no science. The minute you say that,
No,
there's
no.
science.
I'm a scientist.
You're deceived.
I'm a scientist.
You're oblivious to the trouble with what you have. The minute you say that, we can't talk.
I'm saying let's get the issues out on the table. Let's just get the issues out on the table. Let's talk about them. That's my position.
I have my angry teacher face here. I would just like to make one comment that I think helps in sometimes with these discussion is that the Bible tells us that to be a Christian, you have to accept that Jesus died and rose again and that He paid the ultimate debt, the price for sin. So that is the ultimate. I mean, Romans 10:9 and 10 tells us that. The question is, can you be logically consistent in what you believe? So when you start allegorizing Genesis 1 through 11, and you no longer have a timeline that is consistent with the gospel, it doesn't mean that you necessarily are saying that you're not a Christian. But it does pose the point of how can both of those be logically consistent? Because if we look at those first 11 chapters of Genesis, we see that, first of all, God has given us a layout for how He created the world, and Adam and Eve are there in the beginning, and He calls it all good. In a long timeline, we have death, destruction, disease, before sin. So that is a very big logical inconsistency between the gospel that says that death comes from sin versus death brought around humans and then we sinned. That's a huge logical inconsistency that you have to figure out how that's going to fit. And looking at Genesis 1 through 11 from the historical narrative that it's written in fits with the logical approach to the gospel. So it's not totally in isolation, and it's not about who can tell who of us is deceived more than the other. It's about looking at it and going, okay, what is logically consistent with the information that we have before us? And that's that middle ground that you can actually discuss on, because having an argument where one says the other one is deceived and the other one says the other one is deceived ultimately puts us at a stalemate and we can't go past anywhere. The question is, do your conclusions logically work together?
Thank you. You expressed my outlook very, very well. Thank you. I concur. We're pretty much at 12 o'clock, a little after 12. Let's take an hour lunch break and come back at 1 o'clock, and we'll focus on geological issues at this afternoon. And depending on how much time you have, I'm hoping we'll have some good discussion of some of these issues this afternoon. So thanks for your attention.